The corridors here look repulsive, and yet this one leads to some sort of a shrine reconstructed years later when its importance had sunk in.
Let's enter this very special place. We're now entering a sacred location. It's the location where the internet began. It's a holy place, and we've just come back to 1969 when the critical events of the origin began. That machine over there is the first piece of the internet equipment ever installed. It's a mini computer, which we now call a packet switch. This is a military hardened machine. You can't break it. And it was meant to sustain itself unattended for years at a time. This particular machine is so ugly on the inside, it is beautiful. It has a unique odor, a delicious old odor from all the old parts. It consists of modems, CPU, logic units, memory, power supply, all the things you need to make an efficient computer work. This machine served as the first node of the internet for decades. And it was from here that the first message was sent. A revolution began. And the only record we have of what happened that day is in this log. On October 29th, 1969, at 10:30 at night, we enter that we talked to Stanford Research Institute, host to host, computer to computer. It's very much like when on Columbus's ship, the fellow up on top who first spotted land, he noticed it was, and he basically made an entry saying, "We spotted land." That document and this document have at least the same equivalent importance. Now, what was that first message? Many people don't know it. All we wanted to do was log in from our computer to a computer 400 miles to the north up at Stanford Research Institute. To log in, you have to type LOG, and that machine is smart enough to type the IN. Now, to make sure this was happening properly, we had our programmer and the programmer up north connected by a telephone handset, just to make sure it was going correctly. So Charlie typed the L, and he said, "You get the L?" And Bill said, "Yep, got the L." Type the O. "You get the O?" "Yep, got the O." Type the G, "You get the G?" Crash. The SRI computer crashed. So the first message ever on the internet was lo, as in lo and behold. We couldn't have asked for a more succinct, more powerful, more prophetic message than lo. The capacity on the ith channel should be the traffic on the ith channel over the speed of the ith channel plus how much is left over. That's how much capacity is left over, and you split it according to the square root of the traffic on that channel over the summation of the square root over all channels.
The way that the internet works, there's no fixed route that a message takes.
The mean response time now will look like this. It will be equal to the average path length times the summation of the square root of the traffic on the J channel over the sum of all traffics, summed over all channels, squared over mu c 1 minus n bar rho. Whatever that equation means, it tells you what the minimum response time will be for a network once it's optimized. This was a simplified but exact model at the time. Now we have other aspects of it, but it's basically the underlying principles of the network. And one of the things we found, surprisingly, was that the larger the network is, the far more efficient it becomes.
Like a gambling casino that certainly makes money if you have millions of gamblers at the slot machines.
Very much so. You've articulated what we call the law of large numbers. The law of large numbers says that a large population of unpredictable players or messages collectively behaves in a very predictable fashion, a fashion we can write down exactly. And therefore, we can predict the performance of a network when it's large. This room should know I'm here. I should be able to talk to it and should be able to give me an answer verbally. I should ask, where, for example, is a high-speed printer? Or where did I leave my keys? Or where's a book on this subject? And should answer me with speech, with a hologram, with a display, in a very natural way. I should be able to use gestures and touch and even smell and all my senses to interact in a very humanistic way with this technology around us. And once that technology comes out into our physical world and becomes embedded in our walls, in our desk, in our bodies, in our fingernails, in our cars, in our offices, in our homes, it should disappear and become invisible. Whereas electricity, there's a socket in the wall, you plug in, you get electricity. You don't care how it's made, it's not a complicated interface. It's invisible. The internet has yet to evolve to that goal I was hoping for of being invisible. I deeply regret the fact that deep critical thinking and imaginative thinking, and creative thinking is lost. In my opinion, computers, and in some sense the internet, are the worst enemy of deep critical thinking. Our youth of today are using machines to basically replace their examination of the things they're observing. They don't understand what they're looking at or what they're hearing or what they're learning. They depend upon the internet to tell them and decipher it. They look at numbers instead of ideas. They fail to understand concepts, and this is a problem.